Okay, so we're talking about the area between two curves. First of all, a little refresh your memory. Area under a curve. If we need to find the area under the curve of y equals, oops, I can't draw that, y equals x squared from 0 to, let's just call this 2, from 0 to 2, that's just the integral from 0 to 2 of x squared dx, right? And we just do that integral 1/3 x cubed, whoops, yes, x cubed, that was right. From 0 to 2 means you get 8/3 minus 0, so you get 8/3 for that area. Okay, now what we're going to next is if we have the area between two curves. Okay, so the graphical representation first, if we are looking for this area right here, okay, the area of, let's say, we'll call this one f of x and this one g of x. What happens is you're going to find the area under f of x, which is this whole area, okay, and then you're going to subtract the area under g of x, this area right here, and that gives you what's left over, the area in between. Okay, so it's just simply taking the integral of f of x minus g of x, or the top function minus the bottom function. Okay, so an example. This one right here, find the area bounded by the graphs of y equals x squared plus 2, so that is this curve right here, y equals negative x, which looks like this, x equals 0, which is this line, and x equals 1, which is this line. I am not going according to the graph. It's too small. Alright, so I am looking for this area right there. Alright, so we're going to call the top one f of x, the bottom one g of x. Now the bounds are given to us, 0 and 1, so we're going to do the integral from 0 to 1 of the top function, which is x squared plus 2, minus the bottom function, which is negative x, dx. Okay, so that is x squared plus 2 plus x. We're going to integrate that. That is 1/3 x cubed plus 2x plus 1/2 x squared, evaluated from 0 to 1. You plug in 1, you plug in 0. Go ahead and do that. You should get 17/6 for your answer. Okay. Next, we have, sometimes you need to figure out the bounds. Okay, so in order to do that, this one is y equals x squared, and y equals x plus 2. So if it's there, it's going to look like that. So the area bounded by the region is this area right here. You need to figure out what those bounds are. So we set x squared equal to x plus 2, subtract them over, factor, and you get x equals 2 and negative 1. So this one is negative 1, this one is 2. So that tells you what your bounds are, negative 1 to 2. Now the top function, even though it looks like this might be the top function, it's not. The top function is right here. So the top function is y equals x plus 2. That's your f of x. So x plus 2 minus the bottom function, which is the quadratic, x squared. Okay, so when you integrate that, integral of x is 1/2 x squared, integral of plus 2 is 2x, integral of minus x squared is minus 1/3 x cubed, and you're going from negative 1 to 2. Go ahead, plug in 2, plug in negative 1. At the end, you should get 4.5 or 9/2. Okay, so pause the video, go through that, make sure you get your math right. Next one. Alright, so this one is 2 minus x squared, which looks like this, and y equals x, which looks like that. So again, you have to find your bounds. So 2 minus x squared equals x. So I'm going to move everything over here. X squared plus x minus 2 equals 0. So when we factor, it's x plus 2x minus 1. So you get negative 2 and 1. Yeah, that looks about right. So our area would be the integral from negative 2 to 1 of the top which is your quadratic, so that's f of x. So 2 minus x squared, minus the bottom, which is just x, so minus x. Okay, so when you do this one, let's see, the integral of 2 is 2x. That will be minus 1/3 x cubed minus 1/2 x squared, evaluated from negative 2 to 1. You should get 4.5 for this one. 9/2 common answer. Alright, so again, please pause the video, go through that, make sure you get 9/2. Alright, next one. Alright, so this one we have y equals x plus 6. So here's 6, so y equals x plus 6 looks like that. Y equals x squared. X equals 2, which is x equals 2 right here, and x equals 0, which is right here. So this region right here, we have bounds from 0 to 2. They're actually given to us this time. Okay, so our area, our bounds are 0 to 2. The top function is x plus 6 minus the bottom function, which is x squared dx. Okay, so get that, go ahead, pause it. I want you to go through all the steps here. The answer you should get is 34/3. Next, we have this one right here. Alright, again, y equals x squared and y equals x plus 6. This time the bounds aren't given to you. Okay, so the first thing you have to do is find those bounds. So we're going to minus the x and minus the 6. So x minus 3, x plus 2. So you get 3 and negative 2. So our area, the bounds are negative 2 to 3. The top function is your linear function, so this is our f of x, so that's x plus 6, minus the bottom function, which is the quadratic, x squared. Okay, go ahead and do that workout. Pause the video. When you unpause it, you should get 125/6 for your answer. Alright, next one. Sometimes you need to split the area up into two integrals. Now, why would we have to do that? Let's look at this graph. You have 3x cubed minus x squared minus 10x. Yes, difficult one to graph on your own. That is, if you remember from pre-calc, positive in an x cubed, so it starts down and goes up. You know that it's got to go through 0, 0 because there's not another constant out there. So it looks something like that. Doesn't have to be exact. Okay? And then negative x squared plus 2x, this one over here, that's a negative quadratic, so it goes down. Plus 2x, that means that your vertex is going to be, let's see, when you negative b over 2a, do you remember that? So negative 2 over negative 2, so your vertex is at 1. When you plug in 1, you get 1, so something like that. Alright, so the area between the two curves, you've got this area and this area. Alright, so when we do this, you've got to split it up. Because of the fact that in this region, the x cubed function is on top, and the x squared function is on the bottom. And then when we move to this region, it is the g of x that's on the top and the f of x that's on the bottom. Okay? So, if you were to set them equal to each other, so that's 3x cubed minus x squared minus 10x equals negative x squared plus 2x. This is easier than you think to solve. We add the 2x over, those cancel. Subtract, you get minus 12x and 3x cubed. Take out a 3x, you're left with x squared minus 4. So you know that's they're going to meet at 0, at 2, and a negative 2. Okay? X equals 0, 2, and negative 2. Now, this red region, no, it's getting colored blue, goes from negative 2 to 0. Alright, so your area, you have from negative 2 to 0. This one, f of x is on top, so 3x cubed minus x squared minus 10x minus g of x, which is on bottom. Okay, so that's the first one, and then plus the second region goes from 0 to 2. The g of x is on top, so that's negative x squared plus 2x, minus f of x is on the bottom, 3x cubed minus x squared minus 10x. Okay? That's how you do that one. I am confident in your algebra and calculus abilities that you can then figure that out, combine your like terms, integrate, plug in, and get your answer. You should get 24 when you go through that work. Okay. Alright, I believe we have one more. Oh, a couple more. Alright. So, the next one. The area of the region bounded the graphs of y equals 2, which looks like, I'm going to go to a different color. Y equals 2 looks like this. Y equals x looks like this. And y equals 1 over root x. Yes, you might have to use your calculator to do that. That looks like this. So that region bounded is actually this tiny area. My graph may not be drawn to scale. It's that tiny area right there. Okay? So, the reason why we have to split this up is because, and let me expand this out, if you look at this, this is the region. Alright, if this is your axis down here, this is the region. Well, from here to here, you have y equals 2 on top and 1 over root x on the bottom, okay, for that region. And then for the next region, you have 2 on the top and y equals x on the bottom. So that's why you would have to split that one up. Now, the other way to do that one is do that in terms of y. When you do that in terms of y, you basically turn your, I can't show you how to turn your screen. I am going to take this and basically turn it so that this is the top and this is the bottom. Okay? Does that make sense? Let me shoot another color in here. This is going to become your top and this is going to become your bottom. Your bounds are whatever this y value is and y equals 2. Okay? So, to find out what those bounds are, you have to set these two equal to each other because that's this point right here. Alright, so x equals 1 over root x. When you cross multiply, you get x times root x equals 1. So basically, I mean, if you look at that, it's x equals 1, right? Because that's the same thing. It's x to the 3/2 equals 1, so x equals 1. So your bounds, all this is in terms of y, your bounds are from 1 to 2. Alright, this is 1 and this is 2. The top function is this, which is y equals x. So this is all in terms of y. So I have x is on the top. I'm sorry, y equals x is on the top, so that's going to be y on the top. So that is y on the top minus this one right here. Now that means you have to solve this so that it's in terms of y. So right now you have y equals 1 over root x. So if we cross multiply, root x times y equals 1. Root x equals 1 over y, and then square both sides, you get x equals 1 over y squared. So it's going to be y minus 1 over y squared dy. Okay, integrate that, and you get 1 as your answer. Okay, your area equals 1. Alright, there are 2 more examples that are going to be in terms of y. I'm going to do, this has already been almost 15 minutes, so I'm going to stop here. I'll do a second video with the last 2 examples.